400 milliseconds. Think about that for a second, or, well, half a second. It's literally the blink of an eye. But in that exact, tiny fraction of a second, an entire global network is reaching agreement, processing thousands of transactions, and permanently locking them into an immutable ledger. This blistering speed isn't some theoretical lab limit, guys. It's the daily, operational reality of the Solana blockchain. Let's dig into how a system actually moves as fast as information itself.
Welcome to The Explainer. Today, we're tearing into the blueprints of one of the most fascinating networks in crypto to understand how Solana is rewriting high-frequency finance from the ground up. By breaking down the actual source material, data, and research from 2026, we're going to see exactly how this tech is moving way beyond its retail roots and completely hardening itself for institutional-grade finance. We've got a packed roadmap today. We'll start by defining the internet capital market, look at the need for speed, and then balance that with the cost of speed. After that, we'll dive into hardening the network, dissect the massive upcoming Alpenglow upgrade, and wrap things up with the institutional future. Lots of ground to cover, so let's just jump right in.
Section 1. The Internet Capital Market. To really grasp the complex architecture we're about to tear down, we need to understand what Solana is fundamentally trying to be. There's this brilliant quote from the sources that hits the nail on the head. If Ethereum is the oil that settles the economy, Solana is the digital gas. I absolutely love this because it captures the competing philosophies perfectly. Ethereum is functioning as this modular settlement layer. It's the heavy, secure oil underpinning the economy, basically outsourcing the actual execution to layer 2 rollups. Solana? It's built as a high-octane execution environment. It is the digital gas, designed to power consumer-scale applications directly on its base layer.
Section 2. The need for speed. So how does it actually run like high-octane gas?
It all boils down to a fundamentally different architectural choice. You've got Ethereum's modular design, finalizing blocks every 12 seconds and pushing maybe 15 to 30 transactions per second on the base layer, and then you have Solana's monolithic design. Monolithic means execution, consensus, and data availability are all jammed onto a single unified layer. The result? Boom! 400 millisecond blocks and an average of 3,000 to 4,000 transactions per second. But how does it keep nodes worldwide synchronized at that insane speed?
The secret sauce is something called proof of history, or POH. I know, more crypto jargon, but just think of it as a decentralized cryptographic clock. In a traditional blockchain, nodes have to constantly chatter back and forth to agree on exactly when an event happened before they can pack it into a block. It's a huge bottleneck. Proof of history timestamps transactions before consensus even starts. It proves the sequence of events instantly, which drastically cuts down on how much these validators need to talk to each other.
Chronologically, it works a lot like an ultra-efficient assembly line. First, you have this continuous hashing running in the background, literally the ticks of that cryptographic clock. Then, a specific validator is assigned slot leadership on a fixed schedule. These slots are grouped into 48-hour time windows called epochs. Finally, because the exact sequence of events is already mathematically proven by the hashing, the other validators can instantly verify the block and just cast their vote. It's continuous, it's streamlined, and it's wildly fast.
Section 3. The cost of speed. But look, in computer science, there is always a catch, right? This blistering speed doesn't come for free. To really understand Solana's historically rocky network outages, we have to talk about the cap theorem. This is a hard and fast rule of distributed systems. It states that you can only ever guarantee 2 out of 3 things: consistency of data, availability of a system, and partition tolerance. Every single blockchain out there has to pick its poison when the network gets stressed.
Solana is explicitly designed to sacrifice availability in favor of consistency. So what does that mean in plain English? It means if the network gets completely overwhelmed, like by a massive flood of spam bots, it refuses to process bad data. Instead, it intentionally halts. During those pre-2024 outages, you might remember, it averaged about 9.7 hours of downtime to recover. That wasn't a bug. That was a deliberate architectural choice to protect data integrity at all costs. But to be fair, as the software has matured, the network has maintained a 100% uptime streak since February of 2024.
Section 4. Hardening the network.
So how does this infrastructure move from that scrappy startup phase to true, bulletproof institutional resilience? It comes down to fixing operational concentration. Look at validator clients, the actual software running the nodes. Right now, over 60% of validators rely on the Jitos Solana codebase, which itself is a fork of the original Agave client. If there's some hidden zero-day bug in that specific code, it could literally take down the majority of the network. For a world-scale financial market, you simply cannot have that kind of structural vulnerability. You desperately need client diversity.
Enter Firedancer. Client diversity isn't just for Bitcoin anymore.
And we're finally seeing real competition for a monoculture. Firedancer is a totally independent validator client written entirely from scratch in C and C++ by Jump Crypto. It brings exactly the gritty resilience that a world-scale market demands. Think of it as the ultimate insurance policy against network-wide bugs. If the main software completely fails, Firedancer is there to keep the chain alive and running.
Section 5. The Alpenglow Upgrade.
Firedancer sets the foundation, but to hit the absolute physical limits of global networking, the protocol itself is getting a massive rewrite. The numbers here are just wild. Right now, the current consensus mechanism, Tower BFT, takes about 12.8 seconds to reach absolute finality, churning through 32 voting rounds. The upcoming Alpenglow upgrade collapses that down into just 1 or 2 rounds. We're talking a jaw-dropping 150 millisecond finality. But here is the craziest part. They are entirely removing proof of history. Yes, the very innovation that puts Solana on the map is being completely replaced by local timeouts. It is a total consensus rewrite to get near-instant settlement.
And it's not just about raw speed, it's a massive unlock for capacity. Believe it or not, right now, up to 75% of Solana's block space is eaten up just by validators' voting transactions. Alpenglow takes all of that voting and moves it entirely off-chain. So suddenly, 100% of the block is dedicated to actual user transactions. That is a massive boost to capacity, and it significantly lowers the operational costs for validators, an absolute game changer.
Section 6. The Institutional Future.
Bringing this all back to reality, what does a hardened 150 millisecond blockchain actually let you do? Well, these aren't just abstract technical upgrades, they are enabling massive, real-world applications right now. Because of the sub-cent fees, we're seeing the explosion of DePIN, decentralized physical infrastructure, like the Helium wireless network. High-frequency DeFi protocols like Jupiter and Radium can finally operate with the exact same speed as traditional Wall Street order books. And through alliances like the one with R3's Corda, we're seeing serious real-world asset tokenization being brought securely on-chain. The underlying architecture is finally matching the grand ambition.
Which leaves us with a pretty provocative question. As Solana successfully hardens its architecture, rolls out Firedancer, and gears up for the 150 millisecond finality of Alpenglow, will monolithic chains completely bypass modular networks to become the undisputed backbone of global, high-frequency finance? The blueprints are laid out. Now we just have to watch the market build on them. Thanks for hanging out with me on this deep dive, and keep your eyes on the data.